Chapter 2, A Tour of the Book. Chapter 2 defines the three central variables of macroeconomics: output, unemployment, and inflation. It then introduces the three time periods around which the book is organized: short run, the medium run, and the long run. If you remember one basic message from this chapter, it should be: the three central macroeconomic variables are output, unemployment, and inflation. Chapter 2 Outline. Section 2-1 looks at aggregate output. Section 2-2 looks at the unemployment rate. Section 2-3 looks at the inflation rate. Section 2-4 introduces two important relations between these three variables: Okun's law and the Phillips curve. Section 2-5 then introduces the three concepts around which the book is organized: the short run, what happens to the economy from year to year; the medium run, what happens to the economy over a decade or so; the long run, what happens to the economy over a half century or longer. The appendix to the chapter shows the steps involved in constructing real GDP in chained dollars. Section 2-1 Aggregate Output. Economists studying economic activity in the 19th century or even during the Great Depression had no measure of aggregate activity. Aggregate is the word macroeconomists use for total, on which to rely. They had to put together bits and pieces of information, such as the shipments of iron ore or sales at some department stores, or to try to infer what was happening to the overall economy. National income and product accounts were developed at the end of World War II as measures of aggregate output. Measures of aggregate output have been published on a regular basis in the United States since October 1947. The measure of aggregate output is called Gross Domestic Product, GDP. How would you define aggregate output in the economy? Two economists, Simon Kuznets from Harvard University and Richard Stone from Cambridge University, received the Nobel Prize for their contributions to the development of the National Income and Product Accounts, NIPA. GDP versus GNP. GNP stands for Gross National Product. You may come across another term, Gross National Product or GNP. There is a subtle difference between the two: domestic product versus national product. Gross domestic product refers to output produced within the boundaries of a country, whether it is by domestic or foreign firms, whereas gross national product refers to output produced by the nationals of a country, whether it is produced within the country or abroad. Do not worry about this for now. Section 2-1 considers an economy with two firms: steel company, firm 1, and car company, firm 2. Steel company's revenues from sales are $100 and the car company's revenues from sales are $200. Pause for a moment and take a look at all the information provided about the revenue from sales and all the expenses incurred by the two firms. Is aggregate output the sum of the values of all goods produced, that is $300, or just the value of cars, that is $200? Steel is an intermediate good. Which is a good used in the production of another good. Steel is an intermediate good that was counted as output when it was produced. For this reason, we do not want to count it again when the cars are produced. We can calculate the value of aggregate output in three different ways from the information given. Three ways of calculating GDP. 1. GDP is the value of final goods and services produced in the country during a given period. Cars are the final goods produced, whereas steel is an intermediate good used in producing steel. So only the value of the final good produced will be counted in the GDP, which is the revenue from car sales equal to $200. If the revenue from sales of steel is also included, it would lead to double counting. Counting only final goods keeps the GDP from counting a good more than one time as output. So we want to count only final goods, not intermediate goods. If we merge the two firms in the previous example, the revenues of the new firm equal $200. 2. GDP is the sum of value added in the economy during a given period. The value added by a firm is the value of its production, revenue from sales, minus the value of the intermediate goods used in production. In our two firms example, the steel company does not use intermediate goods. Its value added is simply equal to the value of the steel it produces, $100. The car company, however, uses steel as an intermediate good. Thus, the value added by the car company is equal to the value of the cars it produces, revenue from sales, minus the value of the steel it uses in production. $200 minus $100 equals $100. Total value added in the economy, or GDP, equals $100 plus $100 equals $200. So far, we have looked at GDP from the production side. GDP can also be computed as the sum of the incomes in the economy during a given period of time. Any of these methods used to compute GDP should generate similar results. 3. GDP is the sum of incomes in the economy during a given period. Aggregate production and aggregate income are always equal. From the income side, value added in the two-firm example is equal to the sum of labor income of wages earned at the two firms, $80 wages paid by the steel firm plus $70 wages paid by the car firm equals $150, and capital or profit income earned by the two firms, $20 profit of steel firm plus $30 profit of car firm equals $50. So $150 plus $50 equals $200. All three measures of aggregate output give us the same answer. GDP equals $200. The labor share in the example is 75%. In advanced countries, the share of labor is indeed typically between 60% and 75%. Aggregate output, nominal GDP versus real GDP. Nominal GDP is the sum of the quantities of final goods produced times their current price. So in our example, suppose one car was produced and sold for $200, then nominal GDP for that year was $200. Suppose in year 2, still one car is produced, but it sells for $300, then nominal GDP would go to $300. If our goal is to measure production and its change over time, we need to eliminate the effect of increasing prices, i.e. inflation, on our measure of GDP. That's why real GDP is constructed so that we can measure changes in actual output and remove the impact of inflation. Nominal GDP increases for two reasons. The production of most goods increases, the price of most goods increases. Real GDP is the sum of quantities of final goods times constant, not current, prices. So in our example, if we take the quantity of cars produced in year 2, that is one car, and multiply it by constant prices, i.e. the price in year 1 of $200, then real GDP in year 2 will be $200, reflecting the fact that the quantity of final goods produced in year 2 is the same as year 1, even though nominal GDP has increased because of increase in current price to $300. Aggregate output. Numerical example showing calculation of nominal GDP and real GDP. Example above shows how nominal GDP and real GDP are calculated. Nominal GDP for 2011 in 2011 dollars equals 10 cars times $20,000 per car equals $200,000. Nominal GDP for 2012 in 2012 dollars equals 12 cars times $24,000 per car equals $288,000. Nominal GDP for 2013 in 2013 dollars equals 13 cars times $26,000 per car equals $338,000. Real GDP in 2011 in 2012 dollars equals 10 cars times $24,000 per car equals $240,000. Real GDP in 2012 dollars equals 12 cars times $24,000 per car equals $288,000. Real GDP in 2013 in 2012 dollars equals 13 cars times $24,000 per car equals $312,000. Real GDP is calculated using constant or base year or common prices, which in this example is 2012 prices. Nominal GDP, which is equal to the quantity of cars times their current year price, goes up from $200,000 in 2011 to $288,000 in 2012, a 44% increase, and from $288,000 in 2012 to $338,000 in 2013, a 17% increase. However, real GDP goes up from $240,000 in 2011 to $288,000 in 2012, a 20% increase, and from $288,000 in 2012 to $312,000 in 2013, an 8% increase. The problem when constructing real GDP in practice is that there is obviously more than one final good. Real GDP must be defined as a weighted average of the output of all final goods. For more than one good, relative prices of the goods are natural weights for constructing the weighted average of the output of all final goods. Real GDP in chained 2012 dollars reflects relative prices that change over time. The year used to construct prices is called the base year. In the base year, nominal GDP and real GDP are always equal. Figure 2-1 plots the evolution of both nominal GDP and real GDP since 1960. By construction, the two are equal in 2012. Real GDP in 2018 was about 5.7 times its level of 1960, a considerable increase, but clearly much less than the 38-fold increase in nominal GDP over the same period. The difference between the two results comes from the increase in prices over the period. Let us look at the figure in detail. The horizontal axis represents years ranging from 1960 to 2018 in increments of 2. The vertical axis represents GDP in trillions that ranges from 0 to 25 in increments of 5. The graph has two increasing curves. The first curve is labeled as real GDP in trillions of 2012 dollars and rises from $3.3 trillion in 1960 to $18.7 trillion in 2018. The second curve is labeled as nominal GDP in trillions of current dollars and rises from $0.54 trillion in 1960 to $20.6 trillion in 2018. From 1960 to 2018, nominal GDP increased by a factor of 38 as shown by the red curve in figure 2-1. Real GDP increased by a factor of about 5.7 as shown by the blue curve. Nominal GDP and real GDP are always equal in the base year, which in this case is 2012, so the two curves cross in 2012. For years before 2012, real GDP curve lies above nominal GDP curve since 2012 prices being used to find real GDP values for those years are higher. Nominal GDP is higher than real GDP for years after 2012 as prices continue to rise. Think about this. Suppose real GDP was measured in $2,000 rather than 2012 dollars, where would the nominal GDP and real GDP lines on the graph intersect? The terms nominal GDP and real GDP each have many synonyms, and you are likely to encounter them in your readings. Make note of the terminology that will be used in this text. Also note that the base year can change, and at some point in the future it will no longer be 2012. However, in this text, 2012 will be the base year. Nominal GDP is also called dollar GDP or GDP in current dollars. Real GDP is also called GDP in terms of goods, GDP in constant dollars, GDP adjusted for inflation, or GDP in chained 2012 dollars, or GDP in 2012 dollars. Henceforth, when we say GDP, we will refer to real GDP. Y subscript T will denote real GDP in year T. Nominal GDP and variables in current dollars will be denoted by a dollar sign in front of them. For example, dollar Y subscript T. The level of real GDP gives us the economic size of a country. In assessing the performance of the economy from year to year, economists focus, however, on the rate of growth of real GDP, often called just GDP growth. Periods of positive GDP growth are called expansions. Periods of negative GDP growth are called recessions. Figure 2-2 shows growth rate of US real GDP from 1960 to 2018. The horizontal axis represents year that ranges from 1960 to 2018 in increments of 2. The vertical axis represents percent that ranges from -4 to 8 in increments of 2. The graph is a zigzag curve with several rises and falls. Growth in year T is given by yt minus 1 over yt minus 1. In words, real GDP in year T minus real GDP in year T minus 1, and the difference divided by real GDP in year T minus 1. Since 1960, the US economy has gone through a series of expansions interrupted by short recessions. The 2008-2009 recession was the most severe recession in the period from 1960 to 2018. A tough problem in calculating real GDP is how to deal with changes in the quality of existing goods. One of the most difficult cases is computers. It would clearly be absurd to assume that a personal computer in 2019 is the same good as a personal computer produced, say, 20 years ago. The 2019 version can clearly do much more than the 1999 version. But how much more? How do we measure it? How do we factor in the improvements in internal speed, the size of the RAM, random access memory, or of the hard disk, faster access to the internet, and so on? Hedonic pricing addresses this issue. Focus section in the chapter discusses real GDP, technological progress, and the price of computers. The Department of Commerce deals with changes in the quality of existing goods like computers with an approach called hedonic pricing, which treats goods as providing a collection of characteristics. The quality of new laptops, computing services, has increased on average by 20% a year since 1999. The dollar price of a typical laptop has also declined by about 7% a year since 1999. This implies that laptops' quality adjusted price has fallen at an average rate of 20% plus 7% equals 27% per year. Section 2-2 The unemployment rate. Unemployment is another one of the three major variables that give us some indication of how well the economy is performing. Let us understand what the unemployment rate tells us and how it is measured. To understand what the unemployment rate tells us, it is important to know what is meant by the terms employment, unemployment, and the labor force. Employment is the number of people who have a job, even if it is part-time. Unemployment is the number of people who do not have a job but are looking for one. The labor force is the sum of employment and unemployment. Constructing the unemployment rate is less obvious than it might seem. Determining whether somebody is employed is relatively straightforward. Determining whether somebody is unemployed is more difficult. Recall from the definition that to be classified as unemployed, a person must meet two conditions. He or she does not have a job and he or she is looking for one. This second condition is harder to assess. The unemployment rate is the ratio of the number of people who are unemployed to the number of people in the labor force. Unemployment rate equals number unemployed divided by number in labor force, or unemployment rate equals number unemployed divided by the sum of the number employed plus number unemployed. Most rich countries rely on large surveys of households to compute the unemployment rate. The US Current Population Survey (CPS) relies on interviews of 60,000 households every month. A person is unemployed if he or she does not have a job and has been looking for a job in the last 4 weeks. Those who do not have a job and are not looking for one are counted as not in the labor force. Most other countries use a similar definition of unemployment. In the United States, estimates based on the CPS show that in December 2018, an average of 157 million people were employed and 6.3 million people were unemployed. So the unemployment rate was 6.3 divided by the sum of 157 plus 6.3 equals 3.9%. If all workers without a job gave up looking for one, the unemployment rate would go to zero. This would make the unemployment rate a poor indicator of what is actually happening in the labor market. For this reason, we also look at labor force participation rates and pay attention to the number of discouraged workers in the economy. Discouraged workers are those who have given up looking for a job and so are no longer counted as unemployed. The participation rate is the ratio of the labor force to the total population of working age people. In practice, when the economy slows down, we typically observe both an increase in unemployment and an increase in the number of people who drop out of the labor force. So a higher unemployment rate is typically associated with a lower participation rate. What if, in a given month, both employment and unemployment go up? How do you think that might be possible? Why do economists care about unemployment? Although unemployment benefits are more generous today than they were during the Great Depression, unemployment is still associated with financial and psychological suffering. The extent of suffering depends on the nature of unemployment. There are direct effects on the welfare of the unemployed, especially those remaining unemployed for long periods of time. It is a signal that the economy is not using its human resources efficiently, and also very low unemployment can be a problem as the economy runs into labor shortages. Figure 2-3 shows the unemployment rate in the United States since 1960. The horizontal axis represents dates that ranges from January 1960 to September 2018 in increments of 22 months. The vertical axis represents percent that ranges from 2 to 12 in increments of 1. The line graph shows large changes in trend during the period. The graph starts at 5% on January 1960 and falls down to 3.5% on January 1969. The graph continues to rise to 10.8% on January 1982. The graph continues to rise and fall periodically until July 2009, where it peaks at 10%. The graph then continues to go in a decline until September 2018. Since 1960, the U.S. unemployment rate has fluctuated between 3 and 10%, going down during expansions and going up during recessions. The effect of the recent crisis is highly visible, with the unemployment rate reaching close to 10% in 2010, the highest such rate since the early 1980s. Effects of unemployment on happiness are shown in Figure 1. The horizontal axis represents ranges from -4 to 4 in increments of 1. The vertical axis represents life satisfaction index that ranges from 6 to 7.2 in increments of 0.200. The graph is a curve that falls from -4 7.1 to 0 6.2 and rises up to 4 6.9. Results of the German Socio-Economic Panel survey suggest that 1. Becoming unemployed leads to a large decrease in happiness. 2. Happiness declines before the actual unemployment spell. And 3. Happiness does not fully recover even 4 years later. The figure shows three things. First, becoming unemployed leads to a large decrease in happiness. To give you a sense of scale, other studies suggest that this decrease in happiness is close to the decrease triggered by a divorce or a separation. The second is that happiness declines before the actual unemployment spell. This suggests that either workers know they are more likely to become unemployed or that they like their job less and less. The third is that happiness does not fully recover even 4 years after the unemployment spell. This suggests that unemployment may do some long-lasting damage either because of the experience of unemployment itself or because the new job is not as satisfying as the old one. Section 2.3, the inflation rate. Inflation is a sustained rise in the general level of prices, the price level. The inflation rate is the rate at which the price level increases. Deflation is a sustained decline in the price level, negative inflation rate. Deflation is rare, but it happens. The United States experienced sustained deflation in the 1930s during the Great Depression. See the focus box in Chapter 9. Japan has had deflation off and on since the late 1990s. More recently, the euro area has had short spells of deflation. The practical issue is how to define the price level so the inflation rate can be measured. Macroeconomists typically look at two measures of the price level, two price indices, the GDP deflator and the consumer price index. The GDP deflator in year T, P subscript T, is the ratio of nominal GDP to real GDP in year T. It is called an index number, equal to 1 in 2012, which has no economic interpretation. The rate of change of the GDP deflator has a clear interpretation. The rate of inflation can be calculated as pi subscript T equals P subscript T minus P subscript T minus 1 and the difference divided by P subscript T minus 1. In words, inflation rate equals GDP deflator in year T minus GDP deflator in year T minus 1 and the difference divided by GDP deflator in year T minus 1. The GDP deflator gives the average price of output, the final goods produced in the economy. Defining the price level as the GDP deflator implies a simple relation between nominal GDP, real GDP, and the GDP deflator. $YT equals P subscript T times Y subscript T. In words, nominal GDP is equal to the GDP deflator times real GDP, and the rate of growth of nominal GDP is equal to the rate of inflation plus the rate of growth of real GDP. As stated in the previous slide, the GDP deflator gives the average price of output, the final goods produced in the economy. But consumers care about the average price of consumption, the goods they consume. The two prices may not be the same. Indeed, the more commonly stated measure of inflation is the Consumer Price Index or CPI. The set of goods produced in the economy is not the same as the set of goods purchased by consumers because some of the goods in GDP are sold not to consumers but to firms, to the government, or to foreigners. Some of the goods bought by consumers are not produced domestically but are imported from abroad. The Consumer Price Index, CPI, is a measure of the cost of living. The CPI has been in existence in the US since 1917 and is published monthly by the Bureau of Labor Statistics, BLS. The CPI gives the cost in dollars of a specific list of goods and services over time. The list, which is based on a detailed study of consumer spending, attempts to represent the consumption basket of a typical urban consumer and is updated every 2 years. Figure 2-4 plots the two inflation rates since 1960 for the United States. The horizontal axis represents data that ranges from 1960 to 2018 in increments of 2 years. The vertical axis represents inflation rate in percent per year that ranges from negative 2.0 to 16.0 in increments of 2. The graph has two curves which rise and fall at many points. The curve for CPI inflation rises from 1.8 in 1960 up to 14.0 in 1980 and ends at 2.0 in 2016. The curve for GDP deflator inflation rises from 1.8 in 1960 up to 9.0 in 1981 and ends at 1.0 at 2016. The inflation rates computed using either the CPI or the GDP deflator are largely similar as shown in figure 2-4. Recall that the GDP deflator is the price of goods produced in the United States, whereas the CPI is the price of goods consumed in the United States. That means when the price of imported goods increases relative to the price of goods produced in the United States, the CPI increases faster than the GDP deflator. This is precisely what happened in 1979 and 1980. The CPI and GDP deflator move together most of the time. Exception: in 1979 and 1980, the increase in the CPI was significantly larger than the increase in the GDP deflator due to the price of imported goods, oil, increasing relative to the price of domestically produced goods. Pure inflation is a proportional increase in all prices and wages. This type of inflation causes only a minor inconvenience as relative prices are unaffected. Real wage measured by goods rather than dollars, would be unaffected. There is no such thing as pure inflation. Even if the economy experienced pure inflation, it would not be entirely irrelevant. People would have to keep track of the increase in prices and wages when making decisions. But this would be a small burden, hardly justifying making control of the inflation rate one of the major goals of macroeconomic policy. Why do economists care about inflation? 1. Inflation affects income distribution when not all prices and wages rise proportionally. 2. Inflation leads to distortions due to uncertainty. The fact that some prices that are fixed by law or by regulation, and its interaction with taxation, i.e., bracket creep in taxes. Most economists believe the best rate of inflation to be a low and stable rate of inflation between 1 and 4%. If inflation is so bad, does this imply that deflation, negative inflation, is good? The answer is no. First, high deflation, a large negative rate of inflation, would create many of the same problems as high inflation, from distortions to increased uncertainty. Second, as we shall see in Chapter 4, even a low rate of deflation limits the ability of monetary policy to affect output. Output, unemployment, and the inflation rate. The relationship between these three major economic indicators can be understood with the help of Okun's law and the Phillips curve. Figure 2-5 illustrates Okun's law. Okun's law is, of course, not a law but an empirical regularity. It shows the inverse relation between changes in the unemployment rate and output growth in the United States for the period 2000 Q1 to 2018 Q4. Figure 2-5 plots quarterly changes in the unemployment rate on the vertical axis against the quarterly rate of growth of output on the horizontal axis for the United States since the first quarter of 2000 to the fourth quarter of 2018. The horizontal axis represents output growth rate that ranges from negative 2.5 to 2.5 in increments of 0.5. The vertical axis represents change in unemployment rate that ranges from negative 1.0 to 1.5 in increments of 0.5. The clouds of points are dense and a downward sloping line fits them quite well, showing that there is a strong relation between these two variables. Higher output growth leads to a decrease in unemployment. Such a graph, plotting one variable against another, is called a scatter plot. The line is called a regression line. Please review the section on regressions given in Appendix 3 at the end of the textbook. The slope of the line is negative 0.3. This implies that on average, an increase in growth rate of 1% decreases the unemployment by roughly 0.3%. This line crosses the horizontal axis at the point where quarterly output growth is roughly equal to 0.5%. Equivalently, when annual output growth is equal to 2%. In economic terms, what this means is it takes annual growth rate of about 2% to keep unemployment constant. This is for two reasons. The first is that population and thus the labor force increases over time, so employment must grow just to keep unemployment rate constant. The second is that output per worker is also increasing with time, which implies that output growth is higher than employment growth. Suppose, for example, that labor force grows at 1% and that output per worker grows at 1%, then output growth must be equal to 1% plus 1% just to keep the unemployment rate constant. Key takeaway: output growth that is higher than usual is associated with a reduction in the unemployment rate. Output growth that is lower than usual is associated with an increase in the unemployment rate. Okun's law is a relation first examined by U.S. economist Arthur Okun. In figure 2-5, shown on the previous slide, the line that best fits the points is downward sloping. The slope of the line is negative 0.3, which implies that, on average, an increase in the growth rate of 1% decreases the unemployment rate by 0.3%. This is why unemployment goes up in recessions and down in expansions. This relation has a simple but important implication. The key to decreasing unemployment is a high enough rate of growth. The Phillips curve. Figure 2.6 shows core inflation rate versus the unemployment rate in the United States 2000 Q4 to 2018 Q4. Figure 2.6 plots the quarterly core inflation rate on the vertical axis. This rate is the inflation rate constructed by leaving out volatile prices such as food and energy. The vertical axis represents core inflation rate that ranges from 0.0 to 3.0 in increments of 0.5. The unemployment rate is plotted on the horizontal axis. Then we draw a line that fits the cloud of points best. For the United States, quarterly since the first quarter of 2000 to the last quarter of 2018. The horizontal axis represents unemployment rate that ranges from 3.0 to 10.0 in increments of 1. The Phillips curve is a relation first explored in 1958 by New Zealand economist A.W. Phillips. The figure suggests two conclusions. One, the line is downward sloping. Although the fit is definitely not as good as it was for Okun's law, a lower unemployment rate is associated, on average, with a higher inflation rate, and a higher unemployment rate is associated with lower inflation rate. But this is true only on average. Not only is the Phillips curve relation not as tight as Okun's law, but it has evolved over time, complicating in important ways the job of central banks, which have to care about both inflation and unemployment. 2. Using the regression line, we can compute the rate of unemployment associated with a given rate of inflation. If, for example, we want the inflation rate to be 2%, which is the current target of the Fed and many other central banks, the line implies that the unemployment rate has to be roughly equal to 5%. In economic terms, since 2000, when unemployment has been below 5%, inflation has typically been above 2%. But again, the relation is not tight enough that the required unemployment rate can be pinned down precisely. Indeed, in the last few years, when unemployment was below 4%, core inflation was 2.2%, barely above 2%. Section 2.5. The short run, the medium run, and the long run. What determines the level of aggregate output in an economy? Consider three answers. Movements in demand for goods, or how much the economy can produce, i.e. supply, depending on productive capacity of the economy, or the level of technology of the country. 3. The ability to innovate and introduce new technologies, the size of the capital stock, and the education system, i.e. technological change. Each applies over a different time frame. The short run, the medium run, and the long run. In the short run, example a few years, year-to-year movements in output are primarily driven by movements in demand. In the medium run, example a decade, the economy tends to return to the level of output determined by supply factors such as the capital stock, the level of technology, and the size of the labor force. In the long run, example a few decades or more, the economy depends on its ability to innovate and introduce new technologies and how much people save, the quality of the country's education system, the quality of the government, and so on. The book's organization is shown in figure 2.7. The book starts with introduction as a tour of world in chapter 1 and a tour of the book in chapter 2. The mid part of the book is mentioned as core, that includes the short run from chapter 3 to 6, the medium run from chapters 7 to 9, and the long run from chapters 10 to 13. The core has two extensions. The first extension is expectations from chapters 14 to 18. The second extension is the open economy from chapters 17 to 20. After extensions, back to policy is mentioned from chapter 21 to 23. The book ends with epilogue in chapter 24.